Hello everyone, and welcome to this video in a series about data science. In this video, I will talk about these basic concepts and terminology for getting started with data analysis. We will understand what a population is, sample, a dataset, numerical variables, and categorical variables. When we talk about data, we are often interested in understanding or describing a population. A population is all the entities of interest in a study. While it is ideal to have as much data as possible, it is often difficult or impossible to gather all data that makes up our population of interest. Therefore, we try to gain insight into this population by examining a subset of the population called a sample. Now, let's talk about the format of the data that we actually work with. On the right, we have a small dataset, which is a collection of observations and their associated variables. The most common format for tabular data is to organize the observations into rows and their attributes as columns. Here, we are capturing observations of people, and the fields we are interested in are their name, age, and favorite color. Many tools expect the data you pass to it to be in this format, so knowing how to shape or organize your data this way is very important. Next, let's talk about what data types are. A data type tells us what kind of values a variable can store, what operations we can do with it, and how the computer stores and interprets that data. The different types of data types are numerical, categorical, and datetime. We say that a variable is numerical if meaningful arithmetic can be performed on it. For example, we could calculate the average age of the people in the dataset. A variable is categorical if no meaningful arithmetic can be performed on it. We can see name and favorite color are categorical variables. Note, some categorical variables can be represented as numbers. As an example, say we have a phone number or a social security number. Although these are numbers, they do not really represent numerical variables, as it does not make sense to try and sum or average people's phone numbers. The third data type are datetime variables, which represent a point in time. The reason these are treated differently is because some software will let you, for example, add 3 days to a date, and the result would be the date 3 days ahead. Now, let's talk about categorical variables in more detail. We can subcategorize categorical variables into nominal and ordinal. Ordinal variables can have a natural ordering within them, for example, small, medium, large, or cold, mild, and hot. Nominal categorical variables have no natural ordering within them. These can be names, gender, or phone numbers. Encoding categorical variables is more of a general concept than a formal definition, but what it means is to turn categories in the form of text into a numerical representation. Remember, this does not change their variable from a categorical variable into a numerical variable. This is often done more as a convenience when trying to count categories, since we can instead take the sum, or use them in tools that cannot handle data in the form of text. One example of this is dummy variables. In this case, let's assume we had a gender variable, which could only take the values male or female, and we encode them into numbers. Now, male is represented by the number 1 and female by the number 0. The convenience here is that if we wanted to quickly count how many males there are in the data, we can just take the sum of this field. Now, let's talk about numerical variables in more detail. We can subcategorize numerical variables into continuous and discrete. Continuous variables can take any value within a range. For example, height, temperature, or time. These values can be measured with high precision and often come from instruments or calculations. Discrete variables can only take specific, separate values, usually whole numbers. For example, the number of children in a family, the number of cars in a parking lot, or the number of times a website is visited. Binned numerical variables are continuous or discrete variables that have been grouped into intervals or bins. For example, instead of recording someone's exact age, we might store it in ranges that represent infant, teenager, adult, or senior. This is often done to simplify analysis or make patterns easier to see. It is important to note that binning a numerical variable changes the way we analyze it. After binning, it behaves more like a categorical variable, even though it started out numerical. One example, suppose we have a continuous temperature variable recorded in degrees Celsius. If we bin it into cold, mild, and hot, we lose precision, but we may gain interpretability. Finally, let's talk about cross-sectional data and time series data. Cross-sectional data are data of a distinct point in time. Date-time is not usually a field in this data. Time series data are data that are collected over time, and date-time is a field in this data. The intent here is to see changes over time in a particular field. Thank you for watching, and with this video we have gained a better understanding of what a typical dataset is. We are now ready to talk about the types of analysis we can perform on the different data types.